Hello guys, so this is the first lecture of the chapter real numbers. So this is the first video of this chapter. So all your classes throughout your high school, you would have been studying about different types of numbers. For example, you would be studying about what are natural numbers, you would have studied about what are integers, what are rational numbers. So all these types of numbers, what are whole numbers. So all these types of numbers put together, they are called as real numbers. So that is one thing which you have to know first. So any number which can be represented in a number line is called as a real number. For example, what and all do you have in a number line? You have 0, you have 1, 2, 3, 4, which are the whole numbers. If you just take 1, 2, 3, 4, so on, they become the natural numbers. And if you even include the negative numbers, that time you get the integers. So basically all this integers, natural numbers, whole number, and in between two integers, let's say what is this now, 0.5, which you know that you can express as 1 by 2. What is this? This is a rational number. So all these types of number put together is called as a real number. So here in between the 0 and 1, you will also have 1 by 3, which is actually 0.333 and so on, it keeps on going on. So all such numbers as well, the non-terminating reoccurring numbers as well belong to the real numbers. Basically any number which can be found on the number line is called as a real number. So that is something which you have to know in the starting of the chapter. So the first topic or the first theorem in this chapter says every composite number. This theorem is called as the fundamental theorem of arithmetic. So this theorem states every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Basically what they mean is any composite number. So what is a composite number first? Any number which has factors more than itself and 1. More than that, if it has factors, it's called as composite number. For example, if I take now 6, of course 1 is a factor of any number and the number itself will be the factor of that number. Apart from these two, if only these two were the factors, the number itself and 1, that time you would have called that as a prime number. But apart from those two numbers, you also have 2 and 3 as its factors. So you can say that 6 is a composite number. So basically this theorem says that any composite number can be expressed as the product of its prime. Basically if I do the prime factorization of 6, I know that I'll first divide it with the first prime number if it is divisible. So we know that the first prime number is 2. So I'll divide this by 2, that time I'll be having 3 here, and then again I'll divide by 3, that time this becomes 1, 1 here, 1 here as well. So basically I can write 6 as equal to what? 2 into 3. So I managed to write this composite number 6 as product of 2 into 3, and this product which I've written is unique to that particular number. No other number in this world can have its factors as 2 into 3 apart from 6, isn't it? That's why they're saying that the order doesn't matter apart from the order in which the prime occurs. That is, you can also prime factorize this as what? 3 and 2. Basically you can write this 6 as also equal to 3 into 2. So basically what they want to tell is the order doesn't matter, but this product, that is 2 into 3, is unique to a given composite number. So any composite number in this world can be expressed as the product of its primes. Let us take one more example. Let us take 40. So now if I prime factorize 40, first what will I do? I'll divide by 2, that time this becomes 20. Then I'll divide 20 by 2, that time this becomes 10. I'll divide 10 also by 2, that time this becomes 5. 5 by 5 is 1. So I can write 40 as equal to what? 2 cube into 5. So this 2 cube into 5 is unique to this number 40. No other number can have this as its prime factors. So let's go to this example question now, guys. So this is one of the example questions from your NCERT exercise itself. So in this video what we'll do is, since it's the first video, we'll solve all the NCERT exercise and the example questions, or I'll at least tell you people how to approach each type of the question from NCERT first. After that, in the second part, what I'll do is I'll bring out some questions from the previous year papers and from some standard books. So we'll solve those questions and we'll build the concept more strong. So now this question says, consider a number 4 to the power n where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with a digit 0. So basically n is any natural number. So any natural number means n can be equal to 1, 2, 3 and so on, still positive infinite it can go. So they're asking, check whether for any value of n, this number can be having 0 in the last digit. So now if I take n as equal to 1, what will happen guys? This will come 4. Now if I take n as equal to 2, 4 square becomes equal to 16. Now if I take n as equal to 3, what will this become equal to? 16 into 4. What is that? That is equal to 16, 32, 48, isn't it? So what is happening here? Here if you observe, you will see that the numbers are not ending with 0. Let me do one more thing. Let me try for 4 to the power 4 as well. 4 to the power 4 will be what? It will be 16 into 16 actually, isn't it? So that is 256. So here you can observe guys, what is happening? If you observe here, just a minute, 16 into 4. 24 and 64. So this becomes equal to 64, I'm sorry. So what is happening here? Here if you observe, you can observe a cyclicity. There is 4 here in the unit digit, and then 6 comes, and then 4 comes, and then again 6 comes. And then again if I do now this into 4, again 4 only will come in the unit digit. After that 6 will come, and so on, it keeps on going on. Basically 0 will never be the last digit of any power of 4. Now how do you prove this? So we can do trial and error and see that we are able to observe this. But how do you show them as the answer? So you will say that for any number to end with 0, no, there are two product of primes which are important. That is 2 into 5 has to come in its primes, because only 2 into 5 will give you what? Will give you 10, or the 0 will come in the last place of the digit. If there is no 2 into 5, it will never give you 0 in the last digit of the number. So now here 4 to the power n, how can I write this 4? I can prime factorize this 4. 4 I can divide by 2, that time this will be 2, again 2 by 2 is 1. So 4 I can write as what? 2 square. So this becomes 2 square to the whole power n. What will this become equal to? This will come 2 to the power 2n. So 2 to the power 2n, so 2 is being the only prime number, the only prime factor number of 4. There is no into 5 here, correct? So 2 to the power whatever it is, it will never end with 0. So this is how you will write the answer. You will say that for a number to end with 0, the number having 2 into 5 as its product of its prime, when you find its prime factorization, at least 1, 2 and 1, 5 has to be there. If there is only 2, it's not going to end with 0, whatever is the power of the 10. So next question they are telling us, find the LCM and HCF of 6 and 20 by prime factorization method. So whenever the two numbers will be given, and if you have to find the prime, if you have to find the LCM and HCF using prime factorization, what you will do is, first you will prime factorize both the number. So I will prime factorize 6 now. 6 by 2 is 3, 3 by 3 is 1, and then I will prime factorize 20 as well. 20 I will divide by 2, that time I will get 10. 10 by 2 is how much? 5, 5, 5, 1. So I can write 6 as equal to what? 2 into 3, and then I can write 20 as equal to what? 2 square into 5. So now what will LCM be equal to and what will HCF be equal to of these two numbers? So here I can tell you people a trick. This is something which I always tell to all my students. You have to know that LCM is very selfish. This is how I personify LCM as. And HCF, I'll say it is very selfless. What do I mean by this selfless and selfish? So when I say selfish, LCM will take the highest power of the common number which is there, and if there is something not common, it will take that as well. For example, here in the prime factorization of 6 you are having 2 into 3, and in the prime factorization of 20 you are having 2 square into 5. So the LCM, what will LCM do is, it will take the highest power of the common factor which is there. Here 2 is common, 2 is there in both the numbers as factor, so it will take the highest power of that because it's selfish. And then whatever is not common, this 3 is not common and 5 is also not common. The not common numbers also, or the non-common factors also, the LCM will take into it. So that time this will be the LCM value. So this will be 2 square, that is 4, into 3 into 5. How much is this guys? This will be equal to 12 into 5, which is equal to 60. So the LCM of these two numbers will be 60. On the other hand, HCF, as I call it, it's very selfless. What it will do is, it will take the least power of the common factor which is there. So here 2 being the common factor, will take the least power of that. Which is the least power of that? Just 2, isn't it? Because 2 square is the highest power of it. and the other non-common numbers, no, it will not even take, because it's very selfless. Only if there is something common, it will take that, and that too of that common factor also will take the least power. If something is not common, it won't even take it. So the HCF will become 2. So this is how you can find the HCF and LCM, guys. First you will prime factorize, and then for the LCM you will take the highest power of the common terms, and the non-common terms also you will take them. And for HCF, only the lower power of the common term you will take. Non-common terms you won't even bother them. And then sometimes in the question what they'll do is they'll ask you to verify this. They'll say that if there are two numbers A and B, if you find the HCF and LCM, in this case we can take 6 as A and 20 as B. We found the LCM and HCF of these two numbers, and then they'll tell you to verify that A into B is equal to HCF of A comma B into LCM of A comma B. This is a property, guys. Basically, if you take two numbers, if you find its HCF and its LCM, and if you product the HCF and LCM, you will get the product of the two numbers itself. So let us verify this for this question. So here A we have taken as 6 and B we have taken as 20. So A into B is how much? 120. So now let us also see if the HCF and LCM of these two numbers is also giving us 120 or not. So what is the HCF? HCF is 2 as we found it here. And then what is the LCM? The LCM is 60. So now when I do 2 into 60, this becomes equal to 120. So this is the value of HCF into LCM, which is also equal to the product of the number. So this will always hold true, this property. So this happens to be a important result with respect to this topic of this chapter, that the product of two numbers is always equal to the product of the HCF and LCM of the two numbers. Now let's go to the next question, guys. This question I'll give it for you people to try it. The same thing you have to do. You have to prime factorize 96 and prime factorize 404, and then you will see what is the LCM and HCF. You will take the highest power of the common term plus the, not plus, that is into basically of the non-common term as well. Non-common term as well. Highest power of the common term, isn't it? And then HCF will be the least power of the common term, and it doesn't even take the non-common term. So the same thing you have to do for three numbers as well. So one example let me do for three numbers. So first again I'll prime factorize 6. So this becomes 2 into 3. I'll prime factorize 72. Divided by 2 will give me 36. 36 again I'll divide by 2. This will give me 18. 18 by 2 will give me 9. By 3 will give me 3. By 3 will give me 1. And then 120 I'll prime factorize this now. Divided by 2 will give me 60. By 2 will give me 30. By 2 will give me 15. By 3 will give me 5. By 5 will give me 1. So I can write this 6 as equal to what? 2 into 3. And I can write this 72 as equal to what? 2 cube into 3 square. And then this 120 I can write as equal to what? I can write this as equal to, sorry, just a minute. I can write this as equal to what? 2 cube into 3 into 5. Okay, now let's go to the LCM and HCF. So as I said you people that LCM will take the highest power of the common term. So here 2 and 3 both are common in all the three prime factors, correct? So now let's go to 2, which is the highest power of 2. 2 cube is the highest power of 2. Which is the highest power of 3? Here you have 3, here you have 3, here you have 3 square, and here you have 3. So the highest power of 3 is how much? 3 square. Into what will come? Into, you know that LCM will also take the non-common terms as well. So here 5 is being a non-common term, but still it will take it. What will HCF do? HCF being selfless, it just takes the lowest power of the common term. So among this 2 cube, which is the lowest power? It is just 2. Into, out of this 3 square and 3, it will just take one more 3, that's it. 5 it won't even bother it, because it just takes the common numbers. So what will this LCM become equal to? 2 cube is 8, 8 into 3 square is 9, 8 into 9 is 72, 72 into 5 is how much? 360. So the LCM is 360, HCF will be equal to how much? 2 into 3 is 6. So again in this also, yeah, so the LCM is 360 and the HCF is 6. So again this question I'll give it for you people to try it. It's basically a first question of your NCERT exercise. All you have to do is you just have to prime factorize this like this. divided by 2, again divided by 2, 35. So now you know that this is not divisible by 2. You'll go to the next prime number. 3. Is it divisible by 3? No. So you'll go to the next prime number 5. By 5 it is divisible. That time when you divide by 5, you'll get 7. And then 7 as a prime number, you have to divide with 7 itself. So 140 can be expressed as what? 2 square into 5 into 7. The same thing you have to do for all the other numbers as well. So I'll leave it for you.